Hi everyone. So today we'll be seeing general evaluation technique of inverse Laplace transform. So the inverse Laplace transform is given by f of t is equals to L inverse of f bar of p semicolon p tends to t, which is equals to 1 by 2 pi I into integral over t minus I infinity to t plus I infinity e bar pt into f bar of p dp semicolon t is greater than 0. Well, t is greater than 0. To evaluate this, we evaluate the contour integral. That is, this contour integral will evaluate, where c is the contour. So now for evaluating this, we have to integrate this integral. So for this, we can do this by using complex inversion formula 2. So the complex inversion formula goes this way, that is integral over Cp e power pt into f bar of p dp is equals to 2 pi I into summation over n is equals to 1 to and so on, residue of e power pt into f bar of p. So in short, we are adding up the residues and we are getting the value of this integral. So if we take a look and compare this with this, so here if we replace this with this, we will be left with summation over n is equals to 1 to residue of e power pt into f bar of p. So in short, it is the sum of the all residues of e power pt into f bar of p. Then let's see how we evaluate Laplace inverse of f bar of p using complex inverse formula, where f bar of p is equals to 2p square minus 4 divided by p plus 1 into p minus 2 into p minus 3. So let's evaluate this. So one method is by partial fraction method and second method is by complex inversion formula. So for this, first we need the poles. So for poles, we will check out where the denominator value is getting 0. That is p plus 1 is equals to 0, p minus 2 is equals to 0, p minus 3 is equals to 0. So at which point? So p is equals to minus 1, p is equals to 2, p is equals to 3. So all these three poles we got. So we have poles at p is equals to minus 1, p is equals to 2, p is equals to 3. So these are single poles because they are not repeated many times. So then residue at minus 1. First we will take residue at minus 1, then we will take residue at 2, residue at 3, and then we will add these 3 residues. So let's check on how to take out residue at minus 1. So limit p tends to minus 1, p plus 1 into e power pt into 2 p square minus 4 divided by p plus 1 into p minus 2 into p minus 3. So now if you check on, you have to take e power pt into f bar of p into p plus 1. So now this p plus 1 into p plus 1 will get cancelled in the numerator as well as in the denominator. So we'll be left with this portion. Now if you simply substitute the value p is equals to minus 1, you will be getting the answer as e power minus t into 2 minus 4 divided by minus 1 minus 2 into minus 1 minus 3. That is e power minus t into minus 2 divided by 12. That is minus e power t divided by 6. So this is the residue at minus 1. Now let's check on the residue at 2 and 3. So the residue at 2, we take limit p tends to 2. Again p minus 2 we take in the numerator and e power pt, then with the f bar of p. That is 2 into e power 2 into p square minus 4 divided by p plus 1 into p minus 2 into p minus 3. So now p minus 2 will get cancelled. So will be again remain with e power pt into 2 into p square minus 4 divided by p plus 1 into p minus 3. So now if you substitute the value p tends to 2, so as you substitute the value p tends to 2, so e power 2t into 8 minus 4 divided by 3 into minus 1 will be getting it as. So 8 minus 4 is 4. So since in the division it is minus 1, in the denominator it is minus 1, so we we will just take it to the numerator. So it will be getting it as minus 4 into e power 2t divided by 3. Now let's check on for the residue at 3. So residue at 3, which is equals to limit p tends to 3, p minus 3 into e power pt into 2 into p square minus 4 divided by p plus 1 into p minus 2 into p minus 3. Again p minus 3 is getting cancelled. Again we will substitute at this point. So let's substitute. Limit p tends to 3 e power pt into 2p square minus 4 divided by p plus 1 into p minus 2, which is equals to e power 3t into 18 minus 4 divided by 4 into 1, which is equals to 14 e power 3t divided by 4, which is equals to 7 into e power 3t divided by 2. Then now in order to get our inverse Laplace transform, we just have to add all the residues that we have got. That is e power t minus e power t divided by 6 minus 4 e power 2t divided by 3 and 7 e power 3t divided by 2. So on adding it, we get f of t is equals to minus e power t divided by 6 minus 4 into e power 2t divided by 3 plus 7 into e power 3t divided by 2. So in this way we can compute the inverse Laplace transform of a given function f bar of p using complex inversion formula. Thank you for watching. If you have any doubt, please do comment.